Hello everyone. I welcome all of you to the 48th session of the course Energy Law. In today's session, we will examine liability, insurance, and the Nuclear Energy Mission 2025. Let us quickly recap what we have discussed in the previous session. In the previous session, we examined regulatory governance, nuclear safety and security. We started by examining the role of the regulator AERB. Then we examined safety and radiation protection, followed by nuclear security and physical protection, and environmental and disaster regulation. Finally, we also examined need for amendments for better regulatory governance, nuclear safety and security. In today's session, we will examine liability, insurance and the Nuclear Energy Mission 2025. We start by examining the liability framework, followed by the insurance framework. Then we will examine the significance of public-private participation and small modular reactors. Finally, we will examine the Nuclear Energy Mission 2025. Let us briefly examine the background of our discussion. As nuclear energy moves from a state-dominated strategic sector toward a more diversified and innovation-driven energy system, risk allocation and responsibility become defining legal questions. Investment decisions, technology choices, and international cooperation in nuclear energy are shaped not only by engineering capability, but by how law distributes liability, manages catastrophic risk, and enables or constrains private participation. This session provides the background for understanding the legal and institutional conditions under which nuclear power can expand responsibly, attract investment, and integrate emerging technologies while maintaining public confidence and sovereign control over safety-critical activities. The legislation concerning civil liability is the Civil Liability for Nuclear Damage Act 2010. The Act establishes a no-fault operator-only liability regime, meaning that in the event of a nuclear accident, the operator and not suppliers, contractors or technology vendors is legally responsible for paying compensation. Victims do not have to prove fault, negligence or design failure. Liability arises automatically. This structure aligns broadly with international norms like the Vienna Convention and the Convention on Supplementary Compensation, which centralize liability to avoid litigation between suppliers and operators. Under Section 6, there is a cap for operator liability. The operator, NPCIL or any other entity authorized under Section 3 of Atomic Energy Act must provide financial security of 1500 crore, approximately 200 million US dollars. Beyond this, the Government of India act as the financial backstop, meeting additional claims up to its sovereign commitment under the CSC framework. This two-tier system ensures that victims have access to compensation while maintaining financial predictability for the operator. Claims may be filed for up to 10 years from the date of the incident. After 10 years, rights extinguish. A standard provision globally reflecting the difficulty of causation attribution decades after exposure. The contentious clause is Section 17B, which gives the operator a right of recourse against the supplier if the nuclear incident results from supply of equipment or material with patent or latent defects or substandard services. Let us also examine why Section 17B is controversial. Foreign suppliers fear open-ended liability exposure. International practices, especially under CSC guidances, generally shields suppliers from accidental liability. Only the operator bears the responsibility. Suppliers argue that Section 17B creates legal uncertainty, financial unpredictability, long-tail liability risk, and higher insurance cost. This clause has been widely cited as a major contributor for delays in projects like Jetapur and Kovada. We can also see the policy rationale behind Section 17B. India introduced 17B after the 1984 Bhopal disaster, where victims received inadequate compensation and suppliers avoided responsibility. Domestic political pressure demanding that suppliers should bear consequences for defective technologies. Thus, 17B reflects a desire for accountability, concerns about importing high-risk technologies, and an attempt to ensure higher safety standards. Let us examine the Indian Nuclear Insurance Pool INIP 2015. The pool was established in 2015 as a mechanism to operationalize India's liability law. The pool consists of a consortium of domestic insurers led by the General Insurance Corporation, supported by government guarantees. Its primary purpose is to ensure that operators can meet their financial security obligations under Section 8 of the CL&D Act. Provide suppliers, especially foreign vendors, with coverage for the limited recourse they may face under Section 17B, and spread risk across multiple insurers rather than relying on a single entity. The INIP is a hybrid public-private mechanism. A substantial portion of the risk is borne by the Government of India, which provides sovereign guarantees. The remainder is carried by Indian insurers pooling their capacity. The pool's corpus is designed to meet operator liability requirements and to allow suppliers to obtain specific insurance products to offset recourse exposure. The creation of INIP was a confidence building measure aimed at making India's nuclear market more accessible to foreign suppliers. It provides clarity on how compensation will be financed. It creates insurance pathways for both operator liability and limited supplier liability. It reduces the financial uncertainties associated with Section 17B. It also helps projects move from the negotiation stage to deployment, especially in collaborations involving the United States, France, and Russia. Let us examine the significance of public-private participation in nuclear energy. Public-private participation in nuclear energy is a sensitive and evolving subject in India. Although the nuclear sector remains under full sovereign control in accordance with the Atomic Energy Act, the rapidly changing energy landscape, characterized by climate pressures, high capital cost, and advanced reactor technologies, has generated renewed debate about the role of private actors. The Atomic Energy Act 1962 centralizes all authority regarding the production, deployment, and use of atomic energy in the Union government. As a result, private sector participation is prohibited in certain core functions, notably construction and operation of nuclear power plants, ownership or control of nuclear material, fuel cycle facilities or reactors, and handling and processing of nuclear material except as authorized under specific research collaborations. Despite these restrictions, private sector entities can participate meaningfully in manufacturing and supply of components, engineering, procurement and construction roles under NPCIL projects, and R&D collaborations with BARC, IGCAR, and other Department of Atomic Energy institutions. Private entities may also participate in joint ventures with NPCIL, where NPCIL retains operational control, but private partners may support investment or infrastructure. Even without legislative amendments, policy makers and think tanks have proposed innovative PPP structures that maintain sovereign oversight while leveraging private sector strengths. For instance, PPPs in small modular reactors. Small modular reactors, being factory built, modular, and lower in capacity, offer a different regulatory and economic profile compared to large reactors. Proposed PPP structures include private-led design and manufacturing with NPCIL as the operator, private sector financing of SMR modules or sites, and consortium models where Indian industry builds reactors while the government retains ownership and operational authority. This model is attractive because SMRs can be deployed in industrial zones, coastal regions, and even brownfield sites. Other models include joint venture model for PHWR fleet expansion, private construction and public operation, and technology partnerships and licensing models. Given the massive scale of India's clean energy targets, particularly the need to add 22 to 25 gigawatt of nuclear power by 2040, PPP offers strategic advantages. The advantages include faster deployment and reduced delays, lower capital burden on the government, technology infusion and innovation, and strengthening domestic supply chains. Public-private participation in India's nuclear sector is not about privatizing atomic energy. It is about leveraging private efficiency while preserving sovereign control. Emerging PPP models, particularly in SMRs, PHWR fleet deployment, and construction partnerships, could significantly accelerate India's nuclear expansion, helping meet climate goals, industrial decarbonization needs, and long-term energy security requirements. We also need to note that the Cabinet has approved the Atomic Energy Bill 2025, opening the door for private players' participation in nuclear sector. Let us examine the significance of small modular reactors. Small modular reactors represent a transformative opportunity for India's nuclear future. Unlike traditional gigawatt-scale reactors, SMRs offer flexibility, scalability, and lower financial risk. Around the world, SMRs are considered essential for deep decarbonization, industrial electrification, and stable grid operations. Let us see what are small modular reactors. Small modular reactors are a new generation of nuclear reactors that typically produce up to 300 megawatt electrical per unit. Their distinguishing characteristics include factory-built modular construction. SMRs are manufactured in factories as modules. They are transported to project sites for installation, allowing rapid, predictable construction. This reduces both cost overruns and scheduling uncertainties. Another characteristic is that of enhanced siting flexibility. SMRs can be deployed underground or in compact footprints, making them suitable for urban adjacent, coastal or remote locations. Some models allow multiple modules to be added over time as demand increases. SMRs are also passive safety systems. Many SMRs designs use passive cooling, gravity-fed emergency systems, and simpler layouts. These features significantly reduce the risk of large-scale accidents and minimize emergency planning zones. India is exploring a range of technologies including light water SMRs, heavy water SMRs, sodium-cooled fast SMRs, high-temperature gas-cooled reactors, and molten salt reactors. This diversification supports innovation and global competitiveness. Small modular reactors matter for India. It lowers capital cost. It is suitable for remote areas and industrial clusters. It provides for faster deployment. And there is a strong potential for private sector entry. Introducing small modular reactors into India's nuclear ecosystem will require important legal and regulatory reforms. For instance, we need to have new licensing pathways. We need to update the safety codes. We need to have rules for manufacturing and siting. And we need to revise waste management and decommissioning pathways. Let us examine the significance of Nuclear Energy Mission 2025. The Nuclear Energy Mission in 2025 refers to India's ambitious plan launched in the Union Budget 2025-26 to significantly boost nuclear power to 100 gigawatt by 2047 for net zero 2070, focusing on indigenous small modular reactors, private sector involvement, and replacing fossil fuels with clean nuclear energy for baseload power, aiming for 5 operational small modular reactors by 2033. A central objective is the construction of 10 700 megawatt electrical pressurized heavy water reactors in a fleet mode approach. Fleet mode construction means identical reactor designs, standardized components, bulk procurement, and parallel construction schedules. This approach reduces cost, minimizes delays, and builds a consistent supply chain similar to successful models adopted by France, South Korea, and China. The mission emphasizes expanding India's domestic nuclear manufacturing base. This includes indigenous production of heavy components, development of advanced control systems, expansion of fuel cycle capabilities, and greater involvement of Indian industry in fabrication and assembly. The goal is to reduce foreign dependence and build long-term self-reliance, particularly as India prepares for large-scale SMR and advanced reactor deployment. To ensure uninterrupted reactor operations, India has been strengthening long-term uranium supply partnerships as well. The mission also recognizes the need to invest in next-generation technologies that can diversify India's nuclear portfolio. India's Nuclear Energy Mission 2025 signals an ambitious shift from incremental growth to accelerated and technology-driven expansion. Within this, SMRs represent a pivotal innovation, offering flexibility, lower cost, and new partnership opportunities. Their successful rollout will depend on carefully designed legal reforms, a strong regulatory framework, and sustained investment in domestic manufacturing. Let us conclude our discussion. This session demonstrates that the future of nuclear energy in India is closely tied to how liability rules, insurance mechanisms, and participation models are structured and reformed. The discussion brings together the distinctive features of India's civil liability regime, the role of insurance in absorbing catastrophic risk, and the evolving possibilities for public-private collaboration. It also highlights how national initiatives such as the Nuclear Energy Mission 2025 and the emergence of small modular reactors are placing new demands on existing legal frameworks. These elements underline the need for a balanced approach that safeguards public interest and safety while enabling technological innovation, investment confidence, and scalable nuclear expansion. Let's see what's coming up. The upcoming session will explore international nuclear law, trade and technology transfer, focusing on how global legal regimes, export controls, safeguards, and cooperation frameworks shape access to nuclear materials, technology and markets, particularly for India and other developing countries. Thank you.